Major support for Do the Math has been provided by Chevron, the Kern County Superintendent.
Block.
At the beginning of the program, you're going to be over there. I'm gonna
Good afternoon.
some scores and stuff like that, and then I'll wave you.
In the good area,
Wave you on. You come up. Soon. It's working. All right.
Sure.
All right. Big smile, man. Big smile.
She's getting photos right now.
Excellent.
We're gonna grab your. You want to check your mic?
Okay.
So just count to 10.
1, 2, 3,
In French,
4,
young man.
5, 6.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hello, we're live here at Stein, home of the Vikings, and we are here to do
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin, and thank you so much for joining us. Got a great show today. We're going to check back in with Stein Elementary in just a moment. We've got a guest to introduce you to, and this is your opportunity to join us live here on the show. If you're in Bakersfield, you can call us up at 636-4357. In the San Luis Obispo area, this phone call is toll-free to you at 1-866-636-6284. You can always email us your problems at dothemath@kern.org. And of course, you can stream us online at dothemathonline.net. Don't forget to look out for us on social media. We're at your Facebook, we're at your Instagram, we're at your Twitter, we're on YouTube. Join us. Let us be a part of your day because, Mike, we've got a lot to do.
That's right, and as soon as there's something new for social media, I'm sure that'll be added to it again next year.
Oh, let's come up with it right now. We can be right at the forefront. What do you want to call it?
Now, the thing that you brought up about the email. So
Yes.
we want to make sure that when students email us, you preferably do it on a Tuesday or Wednesday.
That's right.
During school, as soon as you get home, something like that at night, but that way we can take a look at it during Tuesday or Wednesday. So if you do it maybe Monday, that would be fine, but if you do it Wednesday night, it's going to be a while until possibly we get an opportunity to look at that. So if you do email us, hopefully you do that on a Monday, Tuesday, or a Wednesday when we can look at it and get right back to you.
Timing's everything. Let's make it work for you.
The San Luis Obispo County thing. That is special because we have a contest going on, and that is kind of in the middle of this contest right now because we've got the rest of October, all of November, and early December. There are a couple of schools that are competing to see which one of the schools can phone in the most. The school that phones in the most, the top students, will have an opportunity to go to Doc Bernstein's Ice Cream Lab, take a look at the ice cream making process behind the scenes at the new facility over on the Central Coast, and the student that phones in the most will win themselves the golden ticket, and that is a Sunday every month for a year. Wow. That's not a bad deal.
Wow.
As Devin said, we do have a very special guest coming in the studio. We'll go out to Stein Elementary in just a few moments, and the makeup people had an easy day with us because we are keeping it low and styling.
Got that shine on.
Anyway, let's first take a look at today's Math in the News. So this has to deal with an article that came out in the Californian on Monday of this week. And we can see there's a little graphic here of the CASP results. And as you know, at the end of every school year, there are students and they take a statewide test. And these percentages, you can see, are based on the number of Bakersfield area students who met or exceeded standards in their state test taken earlier this year, which means at the end of school last year. So we can take a look at the different English and math scores, and you can see how for English, in every district, they're always higher than math. And, okay, so do you have any ideas on why this might be?
There's a lot that you could probably attribute to. I know that when it comes to math, we still look for what those strategies are that are most helpful in the way that a lot of the questions are posed, whereas language arts, it's a bit more open-ended in that regard.
Right, and what they talked about in the article is that this was the first time, I believe, a lot of the students were taking this test in this form. So one of the people that I was talking about, the Director of Research and Planning, I think it's going to take a little bit of time for the students to get used to the test. The format is different it requires more analysis and depth of knowledge. Okay, so that's one reason.
Sure.
Another thing that comes up is in regular classrooms now, and I know that we do this when we go to do on Tuesdays and then when we do some math in your class and things like that, students are put in groups to work on problems together, which usually leads to more collaboration and discussion and helps students learn math concepts better than if they were just doing it on their own. So that is a big thing in the way the students are doing math in classrooms right now. And when you go ahead and take a look at the results one more time here, and we can see the difference between the percentages. And the percentages we can see are usually, in some cases, doubled almost. And what we want to do is, because and a lot of times is students have this thing about, well, I'm not very good at math, my parents weren't good at math, and they say they weren't good at math, so they think that genetically they're not going to be good at math.
And that's not what it is at all. In fact,
right.
Everybody can approach it with that sort of mindset. That's a way of, thinking of a way of, instead of just processing out, how do we solve problems? How do we reason? How do we make sense?
Which is exactly what we try to do on the program, especially when we go out to visit schools and things like that. We take a look at problems and then, all right, does that even make sense? Think about it, reason your way through it, and see if that works and if that makes sense about what you're doing and the process you're going through. In studio with us right now, we have Harshil. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to school at Stockdale Elementary. I'm in 6th grade.
How's 6th grade going?
Good.
Yeah, what's the best thing about it if it's going so good?
Gate.
Oh, you like that? Do you know that in 6th grade, you also get to go to Camp Keep, most schools?
Yeah.
Did you know that?
Yeah.
Do you know anything about Camp Keep right now?
Maybe a little.
Maybe a little. What do you know? I mean, have you heard stuff about it, or have you guys started studying anything about it yet? Do you know when you go to Camp Keep yet?
Yeah, the February 2nd.
Okay, so you've got a little ways to go.
Mm-hmm.
All right, so if you guys, what do you know about Camp Keep right now? Or what have you heard, or what are you excited about?
We get to catch sea animals.
Yeah, we're going to throw you out in the deep ocean. We let you go out there and see what you can go.
Catch or
I'm
be
only
caught.
kidding. You're not
I can't keep. No.
But you are going to have a lot of fun. You're going to learn a lot about sea life and things like that. It's going to be a lot of fun. You're going to remember the week that you go over there for a very, very long time. Probably your entire life you're going to remember. And you're going to be able to attribute a lot of things that you do later on to that week that you're going to learn a lot of things. But I brought you up here right now because we were talking about students working in groups to solve problems a little bit easier. So as part of our Math in the News today, I would like you and Devin to work in a small group to see if you can figure out the number that I'm going to give you clues to, all right? So why don't you guys head on over to the board.
All right. Group time.
And we're going to go ahead and we'll kind of put these up so that you guys at home can see them and you can play along and we'll see if you can figure out what the number is.
He's thinking of a number 1 to 100.
Here we go. The first one. The number is even. So, the first clue tells you that the number is even. So is there anything you would like to do to that 1 through 100 diagram up there to help you out?
Cross out all of the odd numbers?
That's right.
Well, you could do that. Now that's going to take a long time, isn't it?
Yeah.
Okay,
Well.
so what's another way that you could possibly just mark the diagram?
Instead of crossing out every single box, is there something we can use to mark out multiple boxes at once?
So we know the number is even. So is there a way to mark the even columns or even rows?
Yep. Right down here.
So it looks like you're going to circle the entire column. And is this the only column we'll do this with?
Nope.
Okay, what other columns will we want to do this for?
This one.
Okay. Because what do we know about all even numbers?
They either have 0, 2, 4, 6, 8.
So we can circle all of those columns that end in 2, 4, 6, 8, or 0. So we're just about there on that regard. Is there anything we want to do with those other columns in the meantime, just so we don't accidentally go back to them?
Well, right now we'll let them do this part right now. Then we'll go ahead and take a look at B.
That's right.
So it says when you add the digits, you get an odd number. So when you add, so for example, let's say we were going to do 22. If you add up the 2 and the 2, what does that make?
4.
That's not an odd number, is it?
Nope.
So there's something that you're going to be able to do as far as the rows, because when you add up the digits, you get an odd number.
I found it.
Okay, go ahead. So it looks like you're circling all of the numbers in this row that are both even and have 2 digits that add up to odd numbers. And it looks like you're skipping this row as well. Go ahead and continue. So it looks like we've noticed a pattern that's helping us do this a lot quicker, right? So it looks like every single row, every other row, we're circling those even numbers where the sum of the 2 digits is. And now you notice too that we're not going to be circling those that end in 0 as well. So we have 52 here. I'll help you out with 54. And let's see if we can knock these out.
Well, could we do any that end in 0? If we had a 7 and a 0, that would be an odd number.
You know what? Even though we're looking at just these rows, let's make sure we also address the even numbers that are outside of those. So yeah, we can't do the 20 or the 40 or anything like that. But let's look at some of these others in this column.
30.
Okay. Because 3 plus 0. Okay.
70.
I like the way you're thinking.
90.
We're getting there. Do we want to go back up here too?
10.
So let's go, because 1 plus 0, right? That's
Yeah.
going to be odd. So let's go ahead and make sure we get those too. All right.
All right, next one.
I feel good about this.
The number is a multiple of 6.
Ooh, multiple of 6.
So what you can do is maybe mark somehow the ones that are a multiple of 6, because otherwise you're going to be Xing out a lot more than you will be identifying as a multiple of 6.
And we're really just looking for the numbers that have been circled twice right here, right?
Now, I'm going to give you guys a little clue on this. Okay, so let's take a look at the next clue also. So we know the number is a multiple of 6, and it's also a multiple of 4. So if it's a multiple of 6 and a multiple of 4, what are we going to look for then? Could it be a multiple of 12?
Yeah.
Okay, because 6 and 4 both go into 12. So that might be an easier way to take both of those clues and combine them. Make sense?
Yeah.
Okay, so go ahead and do that.
Well, let's start off with Big Daddy 12 here. Is 12 a multiple of 12?
Yeah.
Let's go ahead and keep it. How can we denote that to keep it? How can we mark that up to make it stand out from the rest?
Check it off.
Well, we don't want to cross it out. We want to keep it, right? So maybe if we can put another shape around it.
Square.
We do a square. Let's try that. All right.
Yeah, there you go. Use red, I think it'd be.
What would be in the next multiple of 12?
24.
Okay, is it fit?
No.
Let's skip it. Let's go again. 36. Keep
Yep.
it? Okay, square that. What's the next multiple of 12?
48.
Okay. Do we
Nope.
keep it? No. Next multiple?
60.
Keep it.
Nope.
Next?
72.
72.
Keep it.
Let's keep it. Square that. All right. Next we would go with
84.
84.
Nope.
And then
96.
let's look at 96.
Yup.
Do we need any more multiples of 12?
Nope.
Because we go past 100 at that point. So we have a few choices left. We have 12, 36, 72, 96.
Take a look at the next one. One of the digits is not double the other one.
One of the digits is not double the other one. So let's take a look at the 4 that we have left and see if we could say that about these. So let's start off with 12. One of the digits is not double the other. Can we say that about 12?
No.
Why not?
Because 2 times 2 doesn't equal to 4, doesn't equal to 1.
No, you're right. What about 1?
1 times 1 doesn't equal to 2.
Right, but if we double one digit, does it end up with one of the other digits? So for example, if we double 1, do we end up with 2?
Yes.
Oh, okay, so we can't keep that one. Let's go ahead and cross that out then, huh? All right, let's go to our next square.
1 minute.
36. What do you think about 36? Can we double a digit to get the other?
Yes.
Which one?
3.
So if we double 3, what happens?
6.
And there's that 6 right there, so we got to cross this out. All right, let's look at our next ones. 72.
No.
I think we can keep that one.
Yep.
What about 96?
Nope.
Okay, so we keep it? All right, we got 2 left here.
All right, and I will say that the number is at the very bottom of the chart.
I'm going to go ahead and let you take this one.
That just gave it away.
So, how can we make this as a statement here? We're going to get rid of 72. What's left?
96.
So we think that number is 96.
There you go. Nicely done, boys. And that's how working together you can get that accomplished. And that was one of the items in the Math in the News today. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, out to Stein Elementary and visit with April.
Hi, Mike and Devin. I'm here at Stein, and I'm here with Madison. Madison, what grade are you in? 5th. Say hello to everybody. 5th. Who's your favorite teacher here at Stein?
Miss Torres.
Miss Torres. Why do you like Miss Torres?
Because she's nice. Yeah.
Nice and loud. Okay, so today we are working with fractions, equivalent fractions, and we're going to use a number line and an area model, right? Okay, so our instructions are to take our number line and let's identify thirds. So we're going to identify 0 thirds, 1 third, 2 thirds, and 3 thirds. So if I have a 0 here and I have a 1 here, this is my whole. Now I'm going to divide that into thirds, which are parts of the whole. Okay, so where would I put my dividers to divide into thirds? Okay, go ahead and take the pen off and write it there. So what does that represent? Make a long line. What does that represent right there? How many thirds is that? Nice and loud, so let's write it underneath, 1 third. And then I'm going to separate into another third. Where would I put my marker there? Right there, go ahead. Long line. And that's going to be what? 2 thirds. And I have to also identify my other parts. So here, how many thirds will I have right here? So if I start here, and this is 1 third, then I have 2 thirds. How many thirds do I have here?
3 thirds.
Okay, go ahead and write it underneath for me, please. Okay, and so 3 thirds is equivalent to 1. So what would be the fractional part here?
0 thirds.
0 thirds, go ahead and write that. Okay, so when I cut into fractions, it's parts or pieces of the whole, right? So I've got a whole 1 right here. Let's cut this into thirds. So draw 2 vertical lines down, equal parts. Is that pretty equal? Here, I'll just erase really quickly. Remember, it has to be pretty equal. So just go over just a little bit. Okay, so let's shade that left third of the box. And what does that represent?
1 third.
So if that represents 1 third, let's write that there. And I want to create an equivalent fraction. What I'm going to do is I'm going to take a line and cut it right there, right? So I've created an equivalent fraction. So I'm going to take that, and how many parts did I just cut that box into if I go up and down?
6.
Smaller than that. So if I just go with the red line and not the brown lines, this is how many? Count for me.
2.
So I cut it into how many parts?
2.
2 parts. So I'm going to multiply that by, and what would be my equivalent fraction? How many pieces do I have shaded now of the whole?
2.
2, so that's going to be my numerator. And then how many pieces do I have in the whole?
6.
So that's going to be my denominator. And also with numbers, if I multiply straight across, what's 1 times 2?
2.
And what's 3 times 2?
6.
2 6. 2 6 is an equivalent fraction of 1/3. Okay? Let's do the same thing one more time here. And let's shade just the left there. And what if I cut it into, how many pieces did I just cut into?
3.
3. So if I have 1/3, and I'm going to multiply it by how many pieces? That's how we make equivalent fractions from area models and the number line. Back to you guys in the studio.
All right, thanks for that, April. 636-4357 is that phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Don't forget, if you're calling from San Luis Obispo County, especially one of those 2 schools, well, as a matter of fact, anybody that calls from that county, the phone number is toll-free, and you automatically receive Doc Bernstein's ice cream for simply doing one of your problems on air with us. We have Harshil in studio with us right now, but we're going to let him relax. We're going to go to the phones. And Lovinique, how are you this afternoon? Hello, Lovinique.
Hello.
And what grade are you in?
7.
All right. As soon as you're ready, let's hear the math problem that you're working on.
I'm ready whenever you are.
Let's do this. Go ahead.
Okay, so the question I was answering was, Sam bought 3.5 pounds of hamburger for $3.45 a pound. How much did Sam spend? Okay, so it's a math problem, so you have to go 3, put your numbers on the time thing, and it goes 3.45 and then 3.5 and then go over, and then now you do 5 times 5 is 25. Put the 5 down and put the 2 up on the 4, and then you put 5 times 4 is 20 plus 2 makes 22.
So
Now
it
you
sounds
put the 2
like,
down, and then you put the 2 up there with the 3, and now 3 times 5 is 15, and then it's 3 point.
so Lovinique, it sounds like you've got an approach towards solving this problem. We're multiplying a couple of numbers together to get how much we're paying. And there's a couple of interesting things about this. One, if you multiply these, you might end up with 3 decimal places, and with money, that's not always how we pay with money. So one of the interesting things we can do instead is try to break this down by pound, right?
Right.
So we have 3.5 pounds of hamburger meat. Well, let's go ahead and know that we have 3 whole pounds. We know each pound is $3.45. So let's just make sure we have those $3.45, right?
Mm-hmm.
So
Right.
I'm going to keep those numbers off to the side over here. I want to find what half of that is, because if I can find out half of $3.45, and I know it's not always easy to split because it's an odd number, but if we can find an amount that's
Okay, so if you're trying to get 3 to half, you could take 3, split that in half, that's 150.
Yeah, okay, so we know that half of $3 is $1.50, and we still have that 45 cents.
And then the 45 cents, you could take the 40, divide that into 20.
All right, and then we have 5 cents left.
And then 5 cents left, so you're going to be able to get, it's not going to be an even number with the 5.
No, but we know it's going to be between, let's say, 2 or 3, right? So let's just round up and say 3 cents for that, okay? So we have.
You said the what?
Yeah, we can round up, because if we divide 5 cents into 2, it'll get us 2.5 cents, and we really don't have half cents. So anytime it's in the middle, we can always round up. So that's why we can go with 3 cents. So we have $1.50 that we split. We have 20 cents to that. We have 3, so that's going to get us $1.73. So that's pretty close to half of $3.45. So there's our half pound of meat worth $1.73. So now instead of multiplying this, we can just add these pieces together. And we can just add them top to bottom, right, Levinique?
Right.
We can go ahead and line these up. We have $3.45, $3.45, $3.45, and then that half pound worth $1.73.
Yeah.
And now we just add as normal. 5 plus 5 is 10, and 5 plus 3 is 8. So we have 18, right?
Uh-huh.
We'll bring that 1 here. And we have 3 4, so that's going to be 12. And we're going to have a 1 for 13. And we have another 7 for 20. So we can bring that 2 here. And now we're just adding this dollar column here. 5, 8, plus 3 is 11, and 1 for 12. $12.08 for 3.5 pounds of hamburger meat. And so what's interesting is you multiply that out. When you multiplied that out, did you get something close to that?
Sort of ish. I got $12.75.
75 thousandths of a dollar. But if you look at these values, they are actually very close to each other in value. Because if you round 12.075 up to the nearest hundredth, you'll get $12.08. And when it comes to money, that's usually your best bet when it goes to. So yeah, the multiplication ends up being very close. But as we know with American dollars and currency, we don't go 3 decimal places. We have to make this go to 2. And as you notice right here, this is a great way to make sure you get to where we need to be.
Nicely done. That help you out, Levinique?
Yeah.
All right, very nicely done. And your name is now entered into the drawing to win yourself a couple of passes to any CSCB athletics event. And during the entire year, starting right now, they have volleyball going on, basketball will be coming up, there's wrestling going on, baseball later in the year, so hopefully you'll have an opportunity to go out to one of those events. We do have phone tutors available until 5:30. We have Harshal in studio. Is that what you got, $12.08? Because I said, hey, you do the problem too while you're sitting here waiting, right? All right, Devin, erase the board. Let's get this young man back to work again.
Absolutely.
All right, so this is out of the book that you brought into us this afternoon. Now we'll go ahead and take a look at one of the problems, because I know you're working on equations right now, okay? So this isn't an equation, but what you're going to do is you're going to simplify this. So if you'd like to, you can go ahead and write it up on the board. Start all the way over on your left so you have a lot of room. So we're going to go 2 times, and then open up some parentheses and go 10 minus 2, close the parentheses, and then put divided by 2 to the second power, or 2 squared. Now before you get started, I'd like you and Devin to bring up the fact that you did not write the multiplication symbol in there. And how did you know that you didn't have to do that?
Like, when there's nothing in between these two, the parentheses and 2, that just means it's multiplication.
So that's one of the ways. Yeah, go ahead.
Because it probably gets confusing when you write 2x. If you write 2 times x, they'll just look alike.
So one of the things that mathematicians will use to substitute for that x, especially when we start to get into concepts of algebra, is there's a third representation of multiplication that's very simple. And it's just a simple dot between those two. So for the sake of the visual here, let's go ahead and put that in, because that's going to play a role for when we start making sense of this expression. So based on your experience, what would you start off by doing with this expression?
Exponents.
You'd start off with the exponents. Okay, what tells you that you would start off with exponents?
No, parentheses, because it's PEMDAS.
We'll talk about that in a little bit. So explain what PEMDAS means.
First parentheses, then expression, exponents.
Exponents, right?
Then multiplication, then division, and then addition and a subtraction.
So you said something really interesting there that I hope we can discuss a little bit later on. But I'm going to go ahead and let you jump back into the problem here. So you said you do the parentheses first. I'm going to go ahead and let you do that for us. So you recognize that within the parentheses is the 10 minus 2. So we're going to keep everything else and just evaluate what's in that parentheses, which is 8. And we have the rest of the expression as well. Okay, so now we have 2 times 8 divided by 2 to the second power. What is the next piece of this that we'll evaluate?
Exponents.
Let's go ahead and work through the exponents here. So everything else stays the same except that value with the exponent. Because 2 to the second power is 2 times itself 2 times. So that would be 2 times 2, or 4. Okay, now we have our next piece here, which would be?
Multiplication.
So let's go ahead and do that. Go ahead and multiply first, okay? Okay, and now there's only one thing left to do.
Divide.
Let's go ahead and divide. And you can just kind of go off to the side here.
Okay.
Excellent. So this expression ends up equaling 4. Now, I have a question for you. I'm going to go ahead and move this off to the side. This is something you mentioned with the way that you remembered order of operations with PEMDAS. Multiplication, then division. And I want you to try something for us, okay? I want you to see what happens if we try to divide first here. Okay?
All right.
Go ahead and try to divide first. Okay, so we end up with 2 times 2. And when we evaluate that, what do we end up with?
4.
Was that the same thing that we got when we multiplied first? So does it matter if we multiply or divide first?
No.
So that leads us to another way that people have been thinking of order of operations lately, because sometimes people get caught up in that order that has to be so strict. And I want to get your thoughts on this. It's called gems. Now, a lot of the same idea holds, but it's 4 instead of 6. And let me explain. For G, what we mean is the grouping symbols. Because in math, we'll see more than just parentheses, right? We could see these box brackets. We could see very elegant, squiggly, fancy brackets like this. We can see any of these, but they're all grouping symbols. So we definitely want to do those first. That E still stands for exponents. But then when we get to M, that really represents 2 things. Multiply or divide. Because as we just saw here, it really doesn't matter which one you do first. Whatever comes left to right, that's a preference that some people have. You can do that. And then, what do you think this last one might represent?
Addition and subtraction.
Right, so we can subtract or add. So we think about order of operations. This helps us remember that when it comes to those paired operations of multiplication, addition, and subtraction, we can transpose those however. So let's take a look at this then from that perspective. Here's what I'd like to try, and you tell me why you think this matters.
And I'll give you guys a moment to do that.
What do you think would change if I got rid of the parentheses? How would our approach to this expression change? Without working it out, what would change?
So there are no parentheses. There is no groupings of numbers. So we just hop onto the exponents.
So we would start off with the exponent still, which would get us to 4. So we would have 2 times 10 minus 2 divided by 4. And then what would be the next thing?
Multiply.
So we would end up multiplying to get to 20 here. Get this out of the way here. So we end up multiplying. Give ourselves some more space. We have 20 minus 2 divided by 4. What would then happen?
Divide.
So we would have to divide 2 divided by 4. what would be a good way to express 2 divided by 4?
2 over 4.
Which would be?
1/2.
So 20 minus 1/2.
19.5.
19 point. That's interesting how you shifted from fraction to decimal to find an equivalence there to represent that quickly. Yeah. So absolutely. Now we can really see why order of operations and grouping symbols play such a key role, because they give us 2 completely different values.
All right, nicely done, boys. Hey, do remember we have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Paiute Mountain School, home of the Wranglers, and we're here to Today we're at Paiute Mountain School. We've got 6th, 7th, and 8th graders here. We're going to do a couple of math activities, and we're going to go ahead and get started. You guys ready? Yes. All right, let's go. So, first thing, if I have a grid, and let's say I'm going to do it like this. And I roll a die, okay? And it can go anywhere from 1 through 6. And let's say I roll a 2 and a 3. And I have to multiply those. What will I get?
6.
6. So I'm going to shade in 6. And it doesn't matter where I shade them in, okay? But I must shade in 6. So I can either do a 2 by 3, right? Where I go like this. Or I could have done a 3 by 2. Do you agree with that? I could have done it a different way. I could have even gone just 6 across the bottom. All right? But I decided to do that. The next one I do, select 2 numbers.
7 and 8.
Well, it's got to be on a regular die, so between 1 and 6.
So 5 and 2.
5 and 2, so that's going to give us 10. Okay? So I am going to stay right here. I'm going to do a 2 by 5. All right? So I'm going to go down 2. And across 5. Everybody good with that? Are there other places I could have done that? Yes. Obviously other places I could have done it, right? So, give me another 2 numbers.
3 and 4.
3 and 4 is going to give me 12. So I'm going to go 3 by 4. So I'm going to go, here's my 3 by 4, and fill them in. All right. Now I could have done it a different way, and it doesn't always have to be like a rectangle like that. It could have come up and over a little bit. Do you guys agree with that?
Yes.
All right. So give me 2 more numbers.
4 and 2.
4 and 2. Going to give me 8. 1, 2, 3, 4, 5, 6, 7. Ooh, I can't do a 4 and a 2. All right. So that's not going to work. All right. So what other numbers could I possibly use? Do you have 2 numbers that might fit? 2 and 3 gives me 6, right? So I can go 1, 2, 3, 4, 5, 6. Was there any possible way for me to load in all 7 of those? Because I got 6 and I've left with 1 left over. Is there any way I could have possibly gotten all 7 of those completely filled in?
Yeah. Yes.
What way could have I done that?
By getting 1 and 7.
But if we're doing a regular die, it's only going to go 1 through 6. So what could I have done?
Put 1 times 1, and that would fill up that 1 square.
Right, I could do a 1 by 1, right? And that would fill in that square. But let's say I had 7 and I wanted to get it done. So we could do like we did. A 2 by 3 and a 1 by 1. That will give me 7. Any other combinations we could have done in 2 rolls to get 7?
5 and 2.
Right, we could have gotten a 1 by 5 and a 1 by 2. Any other ways we could have gotten 7?
then.
That 2 and 5.
3 and 4.
3 and 4, right? We could have gotten 1 by 3 and 1 by 4. Okay, so there's a lot of different ways we could have gotten to the 7. So that's going to bring us up to probability later, but first we're going to do this activity. You guys ready? All right. So here's what's going to happen. This was just a random grid that I put up. You guys are going to have to see how close you can get to 100 to fill in the 100 just by multiplying the dice. Okay, so whatever numbers you roll, those are the ones you have to use, and then you're going to shade it in and see who can get the closest to filling in the 100. You guys good? Yeah. All right, let's go ahead and pass this out, and when we come back next time, we're going to see who can get the closest and how far they may have been off. And a special thanks to Kathleen Hansen, the principal out at Paiute Mountain School. We had a wonderful time out there, a lovely drive, nice and scenic, and we had a wonderful time out there. The students were great to work with. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Harshill's in studio with us, but right now we're going to go back out live to Stein Elementary, check out what's going on with April.
Hello, gentlemen. I'm here back live at Stein, home of the Vikings, and now I have with me from the 5th grade, Justin. Justin, you gonna say hi? Hi. Amani.
Hi.
And Sebastian.
Hi.
They're all in the same class. And what do you guys like? What's your favorite subject here at Stein?
Math. Mine's math.
2 maths and a science, all STEM. Love it. Okay, so this time we're going to be working on 5th grade long division, 2-digit, and each person is going to have a problem. So go to your problems. And we're going to start off with Justin here. Hold on, you guys. We're going to start off with Justin. Justin, we are dividing 828 by 92. What's the best way we can do that?
Subtract 92 until we get something lower than 92 on 828.
So we're subtracting 92 until we get something lower than 92. Okay, so I'm going to set you off. You're going to start with 828 and start subtracting 92? Okay, you go ahead and go, and I'm going to start talking to Sebastian. Is that okay? All right, I'll come back and check on you. Sebastian, you have 210 divided by 15. So what's your process going to be?
21 minus 15.
So why are we subtracting 21 minus 15?
Because
you need to see what?
Because 15 could go into 21.
So I need to see how many 15s there are in 21, and I'm going to use subtraction by doing that, right?
Yeah.
Okay, so you're going to set off. I'm going to come back and check on you. And lastly, Amani, what's your process going to be?
My process is going to be multiplication. So basically I'm going to take 45 and times it 8 times.
Okay, so let's start here. And what does that look like? So you're going to take 45 and multiply by 1.
45 times 2 equals 10, carry the 1, 8, 9, 90.
Perfect.
45 times 3 equals 15, carry the 1, 12, 13, 135. 45 times 4 equals 20, so carry this 2, 16, 17, 18.
And we'll come back until you get to 8. Sebastian, what do you have going on over here? So you subtracted 15 from 21.
Mm-hmm.
Okay.
And I'm borrowing the 1 from the 2.
Because you can't subtract 5 from 1.
Yeah.
It's too small, so you have to borrow. Okay, go ahead. And when you do that, you're going to subtract, right?
Yeah, and I got 6. And then after that, I bring down the 0 and I got 60.
60? So what do we do now?
60 minus 15.
So I'm still taking away the 15. Why are you taking away 15? Why do you do that?
Because you always, because the 15's right here, because you have to subtract. Because of the division is.
And division is doing what?
Okay, so addition is going forward.
Yes.
And even multiplication goes forward.
They get bigger.
Division and subtraction goes lower.
Lower. So you're subtracting because actually multiplication is repeated addition and division is actually repeated subtraction, right? And it looks like somebody's got some repeated subtraction going on here. What are we doing over here, Dustin?
Over here, I
Justin.
subtracted. I subtracted 828 with 92. Then I got to 0.
So we're subtracting what every single time?
Uh,
What number do we subtract every single time?
92.
92. So how do I find out how many 92s there are in 828? How do you know what the answer is?
You count how many times you subtracted.
So let's count. How many times did we subtract 92?
1, 2, 3, 4, 5, 6, 7, 8, 9.
9. So that means that 92, 828 divided by 92 is, how many times did you count 92?
9.
9. Okay, let's go over here and let's take a look at what's going on over here. You're done? What did you do over here, Speed Demon?
So I did all to 8.
Okay.
Then I did how many times 45 can go into 76.
And you got that from the 1 here.
So that's
Okay.
1. Then I multiplied and then I subtracted.
Okay.
Bring down the 5.
Okay.
How many times 45 can go into?
And you have a whole plethora of answers over here, so that's easy to pull from, right?
And that's 0.
Great job. What are we doing over here, sir?
Huh?
Huh? So you got 60 and you're subtracting 60 by 15 every single time. And how many 15s did you subtract?
4 times.
So 210 divided by 15 is?
14.
Great job, Sebastian.
There.
And you're done too? Yeah. Come back over here, you guys. Let's say goodbye to everyone in the studio. Say back to you, Mike.
Bye.
Back to you, Mike.
April, don't let him go too far because we do have one more opportunity to go out to Stein. In the meantime, we're going to have young man Harshill do some work. Over to the board, young man. Here we go. Let's take a look at another problem in your book. Math on the spot. And we're putting him on the spot right now. The 3 sides of a triangle measure 3x plus 6. So if you want to draw a triangle up there.
Yeah, let's go ahead.
So we have one side is 3x plus 6. And these are all in inches.
There we go. So one side is 3x plus 6 inches.
Another side is 5x.
We have one side that's 5x. He's labeling his unit there, making sure we're getting inches. 5x inches.
And the third side is 6x inches.
And our third side is 6x inches.
Now the question says, write an expression for the perimeter of the triangle, then simplify by combining like terms. So write an expression and simplify it.
What do we know about perimeter?
You add the sides up.
Right, so the perimeter is the distance around the outside of the shape. So now, if we were going to do that, what would we need to be able to do?
Add the sides up.
Sure, so what are the values that we'd need to add here?
6x inches, 5x inches, and 3x plus 6 inches.
So could you go ahead and write that out just so we know what we're going to need to add up here? So we're going to add 3x plus 6 plus 6x plus 5x. So what I thought was really interesting is that you had put the unit here of inches with the 3x plus 6. And then as we went on, that kind of went away. But are all these inches? So maybe we can take that unit and put that to the outside here. Just a moment. So let's say we have our 6 inches here. All right. So we'll make sure that whatever this ends up being is going to be in inches. Just brought it back over there. So now we're adding all of these values. Now, is it as simple as adding everything here together?
No.
So what do we have to keep in mind?
Adding like terms?
So we have, I mean, they all have numbers. They all look alike to me if I'm just looking for numbers, but that's not really all I'm looking for, right? What do I need to see that I can add?
C numbers that have an X on the end and C numbers that are just by themselves.
So like terms are terms that share the same variable, and not necessarily by a coefficient, but when we see the same variable, we can combine those coefficients. So what terms can we combine that are like?
3x, 6x, and 5x.
So how would I combine those?
Just add them together.
Add them together. So all right, am I adding all the x's together?
No.
Okay, so what would I be adding together?
The numbers.
Just the coefficients, okay? So I have 3, 6, and 5 as my coefficients. Let's go ahead and add those together. Okay, so I have 3 plus 6, that's 9, plus another 5, that's 14. I have 14x. I have this plus 6 here. What are we going to do with that?
Just drop it down.
There's nothing else I can add that to, huh? So let's go ahead and bring that in with the 14x. So what does that mean in regards to the original question? So what does this 14x plus 6 represent in our work here?
We just simplified this.
And so what did we end up finding?
The perimeter.
So 14x plus 6 inches, I still have my shape over here, that ends up being the perimeter of the entire triangle. No matter what vertex we start at, no matter what point along the outside, when we return, we'll have gone 14x plus 6 inches. Now maybe we don't know what the value of x is, but whatever it is, we can plug that in and find the true perimeter as a value. Nice job on that combination.
Nicely done, combining like terms. And Harshil, since you've done an excellent job today, we have a couple of gifts for you, and which includes a free movie pass from our friends at Maya Cinemas. So congratulations on that. A lot of movies out, and if there's not one you like now, hold on to it. Wait for a good movie to come out. You can go check out whatever you like. Hey, we do have phone tutors available until 5:30. The phone numbers are at the bottom of your screen periodically throughout the program. As a little note also, remember, if you're going to email a question, it's preferable that you do it on a Monday, Tuesday, or a Wednesday. That way we can address the question and get it back to you in time. Possibly some of them we do them on air also, and that way you can also view the problem being completed as well. We have an opportunity one more time to go out to Stein Elementary and visit with April.
We want to take one. Hi, gentlemen. We are back here at Stein, the Stein Vikings, and I am here with Amir. Amir is in what grade? Sixth grade. So today, Amir and I are going to work on, what are we working on?
Patterns.
Patterns. So talk to me about what's going on here, Amir. How would I identify patterns?
I think that...
What do we know? Talk about what do we know? We know that, up here, from up here, what do we know? What do they tell us in the beginning?
Oh, we know that,
What does it say?
9.
9 times
10
is?
90.
That's what we know. Okay. So if I'm looking at patterns, and now I have a 900 here, this, has it changed?
Yes.
And has this changed?
No.
Okay. So that means this is going to change. So what number can I multiply by 10 to get 900, and how do I know that?
90.
So let's write 90 there. And how do you know it's 90?
Because in 9 times 10 you get 90, and if we're going to get 900, you got to do it by 90.
Okay, so I have how many zeros here?
1.
And how many zeros here?
1.
1. How many zeros do I have here?
2.
2. How many zeros do I have here?
1.
1. So how do I get 2 zeros? I have to have
9.
a 0 here, right?
0.
Okay, so 9 times 1 is 9. 9 times 1 is 9. 9 times 1 will always be 9. Okay, so now I have this pattern. I've got 900 times 10. So what's that going to give me?
9,000.
And how do you know that to be 9,000?
Because
We're looking at zeros, looking at the pattern. What do we see?
oh, well, since now that this is over here,
Okay.
I think that you just add a 0.
So that's what we did. How many zeros do we have?
2. 3.
3. How many zeros do we have?
3.
Perfect. Now this is over here. What's the next pattern? What do we do? So I have 9,000 times 10.
So you have 3 here, and we have 1 here. So we're gonna take this right here.
Okay.
And it's gonna end up being 90,000.
So in this next one, we have to fill in a lot of blanks. What goes here?
90,000.
And if I multiply that by 10,
Okay, that's gonna get 900,000.
900,000?
Yes.
Because I have to take that 0, add it to the end, and 90,000 times 10 is? Perfect. So do you see some relationship between the numbers being multiplied and the answers? What happens when you multiply by 10?
You add 1 to your number.
Add 1.
0.
You add a 0 to your number, right?
Yes.
Great job. Okay, let's compare some numbers. I'm going to compare, do you know what this symbol is?
Greater than.
Greater than, and this symbol is?
Another greater than.
How can they both? How can they both say the same thing? So this one is
greater,
and this one is
less than,
and this one is
equal.
Okay. So what happens when things are greater? One number has to be bigger, and less. The other number is
smaller,
and then equal.
Same.
So 3,003,267 is what in comparison to the other number you see there?
Equal.
How do you know they're equal? Go ahead and write that.
Because if we look at this one,
what place is this?
1 million.
1 million. So do we look at the 1 million place? Or what's the easiest way to check this out? Do we start here?
Yes.
And then what do we do?
Go down.
Go each number?
Yes.
Check number by number?
Uh-huh.
And has there been any changes?
Nope.
That's why they're equal. Talk to me about this. When I compare 77,392 and 67,993, what do I know?
We know that this one's bigger.
Why?
This one's smaller because if we go down the road, they're not. This one's smaller.
We can just stop right here because this one's greater, right?
Yes.
Okay, so if this one's greater, what symbol should we use?
This one because it wants to eat that one.
Okay. Let's turn around. Thank you, Amir. Very good job. And we're going to take it back to you in the studio. Thank you.
Thanks for that, April. You know what? We've got one more thing to do, and that's give away 2 passes to any CSCB athletics event. All right, she'll go ahead, put your hand in there, pick out one of those names. All of the students at Stein are in there, as well as Lovenique. And who is it?
Sebastian.
Sebastian. So congratulations to Sebastian at Stein Elementary. You've got yourself 2 passes to any CSCB athletics event. That must be Sebastian right there, ready to go. All right, and we're ready to go. Hey, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.